1, 2, 3. Okay. So we're going to be covering NFC, cryptography, and kind of like a little bit of touching into networking. So what does NFC stand for? Near field communication, right? If you wanted to compare it to something else that you might have heard about, RFID, which stands for radio frequency identification, is kind of like you can think of it as the predecessor for NFC, right? RFID didn't have any sort of capabilities, kind of interaction, right? So NFC is kind of building off of that. NFC, certain interesting application for NFC is let's say you have a Bluetooth speaker, right? And you want to pair it with your phone. I can't remember which ones might have it, but they were at one point they had a product where you just tap them together, right? And they'll transfer information between them, right? So NFC has more than just one-way capability. That's why it's not near field identification. It's near field communication, right? There's also the difference of how far you can scan a chip from. So for RFID, you have about 10 meters. NFC has around 10 centimeters, right? So massive difference. How you might ask how those NFC tags are powered, right? They're actually powered just from the electromagnetic field that's generated by a reader, right? So that juice is kind of like it flows through, and since the amount of actual space on a tag is really, really small, it doesn't require a lot of power to run, right? And then each tag has essentially three components, right? You can kind of see it on this large one. You have the antenna, right? So this is what receives the signal and receives power from the electromagnetic field that the reader generates, and which receives the communication, right? And you have a tiny IC, we call it a processor, integrated circuit, kind of really small, very precise on what you can do. And then you have your memory. This is another diagram. Does that make sense? Any questions? No? Okay, so another thing to think about is NFC standards, right? How do we store the information within the chip itself? So I'll drop the links for some of the documentation if you want to check it out yourself. Right, and these are kind of large. You can think of them very large specification files. So if I open up the first one, okay. You can see it's a pretty large file, about 25 pages. And this all goes into specifying how we want to store data into the text, right? You can go very, zoom in a little bit, but all these links. NDEF, which is what we're interested in, there's multiple different standards of storing information within NFC tag, but this is the one we want to implement, and it's kind of the most widely used one, right? NFC standards are there's a general commonality between them, right? But some might be different. If you look at smart cards, those operate in a completely different kind of storage system. You have certain chips, NFC chips that also have password protection. You can kind of hide what's inside of it, right? But we'll be focusing mainly on NDEF. Let me show you, if you go through that file, you'll find, or if you search up NDEF, you'll find this diagram, right? Okay. Okay. So you can think of it as just a big string of numbers, right? And then within those you have blocks, and those are NDEF records, right? So you can have multiple different records on the same tag, and each tag has all these kind of like payload ID, payload type. So this payload type is specifying what kind of data is being stored in the tag itself, right? And then kind of this length, how long is the data that you're saving? Message begin, message end, bit. That's how you store it all. One big chunk. Is that good? Any questions about that? Okay. Oh, okay. And then now it's time to try it out yourself. So if you pull up on your phone and search up NFC tools, should be one with the orange icon.
So we just install it?
Yes. This one? There should be one with the orange icon.
Would you have them be Paul?
Yeah.
Hey, hey, nice to meet you.
Thank you.
Wait, are you on the tool? What's it? Search of NFC tools. NFC this one. Hold on, it should be exactly tool. Space tool. With this tool. This one. Yes. Okay, so now you should have, everyone should have a tag, and you should have the app installed. Okay. The first thing I would like you to do is go, let's see, tools, and press read, right? On iPhone, since they kind of have NFC kind of locked down more than Android, you have like a pop-up to scan. For iPhone, I know the scanner, since you know it's a short range, you have to find sometimes where on your phone it is. So for iPhones, it would be, I know it's in the top left for the majority of them. So if it doesn't work, read. I'll put it up top left, and then it'll read it. But it might change. Might be different for your phone. And then it should pull up like information about the tag. So tag type. So it'll tell you NTAG 215. So that's if you search it up on Amazon, this is what you have, right? And then it's telling you, it should say ISO 14443-3A, right? That's that's going into specifications, right? ISO specified tags. And then you have a serial number. Each tag should have a unique serial number, and it's stored in 1, 2, 3, 4, 5, 6, 7, and like 7 cells. And then it'll tell you a little bit about it. How many pages it has? 135. Pages are just considered like a block of data, right? You could call it a block, pages, depending on what where you are in your terming. Some people call them blocks, some people call them pages. I think that's also similar to if you go and take 2312, they'll talk about, they'll tell you about how in different industries you might have the same name but for different things, and different names for the same thing because of how the fields kind of like develop separately. And then the data format, which isn't really that important. And then it tells you that it's writable, right? Now, the second thing I want you to do is if you go, there should be an other tab, another other button. If you go to other, and then there should be read/edit memory. There's a paid version app. You don't need to do you need to pay for it to be able to use the specific reading and writing. But I only want you guys to see what's inside the tag. So for me, it's I can see each block, right? So it's telling you address 0, address 1, and counts all the way down. Since we know it's 135 pages, it goes 135 pages, but it only goes down to address 86. Okay. Oh, yeah, the blocks. So it should go to 135, but I'm not sure why it isn't for me. But you can see what's being stored in those, and those are being stored in hexadecimal. So is anyone not familiar with what hexadecimal is? Okay, just need to ask. So everything that's being stored in there. Now to learn a little bit about NDEF, right? Everything that the app stores into the tag is stored in NDEF definition. So if you go back out and go to write, you can add a record. A record is just these NDEF records here. And let's say you put in text. What I would recommend doing just to see like kind of where the data is being stored, I just put the same number back to back. So for me, I'm going to put 9, a bunch of 9s in.
It's not reading.
It's not reading? It's not telling me that. I think someone told them that it's probably passed, but since it's not saying it might be somewhere, you have to try that. You try to should. If you want, I can show you what it is after. You have any questions?
Do we press the third option?
The option, right?
Yeah.
Yeah. Okay. So now you have the record set up, right? And now you want to write it. So you just press write. Then you bring up your tag to it. And now you've written to this tag, right? And now if you go back into the same page reading, right? Same other read/edit memory, you can see that the data portion has been filled with stuff, right? So if you put the same number back to back, a bunch of 9s, I put a bunch of 9s, so I see it's like the beginning starts 6E and then it goes 39, 39, 39. That's the hexadecimal representation of those 9s. If that makes sense. Yes. Oh, so you're making a record. So you write, and then you just press add a record, the text, and then write that to the tag. And then you can go and check the actual what's the word where it says data. So I think you can see where it says you search up that sounds a little bit representation. It'll show you.
Gotcha.
So that's where your lines are being stored. And then kind of like the information before those 30 lines, kind of how it encapsulates that data, right?
Yeah.
So now if you write to the tag, right, so press right, and then you bring the tag up. Yes. And then now if you go back, and then go back into other again, and then press read/edit memory, and you scan it again. You'll see like address 6 will have like repeating numbers. That's where the data is. You see, so this is the binary. This is binary. This is the hexadecimal representation of the binary data that's in the tag. Right, so you see where these 3 lines are, because that's where another function lines. I know it's the 9 representation of binary in hexadecimal. In the text. You could go back to the right. And then you can put snap. Just go to you can put anything as long as it's the same, so that you can see where in the data is being stored. Then you have to write it. So if you go to where you're looking at the record, go back to where you're reading the record. So right. And then there's another right. So right. And then now you write it. And then now if you go read the other, I mean, you can see it from the read, or if you go to the more advanced, you go back out to other, and then read and edit memory. It'll show you exactly what's in there. Go back out. Press other, and then read and such a and then also it's in the upper left. And now you can see each address what's being stored. So 39 is the 9 representation of 9 X's. So now you can see where you saw before where okay. All right, and then now I'll talk a little bit about communication standards, right? So the way the reader communicates with the Raspberry Pi is over a communication bus, and the common communication bus would be SPI, I2C, and UART, right? In this example, I'll be using SPI, right? And I have these connected into the GPIO pins, just depending on where you're specified in the program. I'll also drop a link to the GitHub that has the code that I'm running to read from it. So now let me set up the Raspberry Pi really quick. I'm VNC into it, which is kind of SSHing into it, but it gives me direct feed into it, into the Raspberry Pi. So if I can, Okay. So now I'm going to demonstrate using the library. So I have the library stored here. So this is the Pine 532 library. These are the main files, right, that are used to compile. And then these are the examples. So depending on what you're using, an Arduino, Raspberry Pi. I'm unfamiliar with STEM, what STEM 32 is. You have these files. So if I show you in the terminal, so CD into PN, I'm going to go into examples. And then for this example, I'll show you what it looks like dumping out all the data, right? So running Raspberry Pi dump ntag2, right? So they're different. So you guys all have ntag 215. There are other, I don't remember the exact numbers, but they correspond to having more memory on the tag itself. So these have 500, I think around 502. So if you scan them, you can see how much memory they have. So if I read this, 540 bytes, right? And that corresponds to 135 pages and 4 bytes each, right? So I'm going to run, if you do download this on your Raspberry Pi and you want to try it out and you do happen to have a reader and writer, if you don't see these, you just type make, right? And it'll make these executables. And then I'll go and run one of the dump, right? Now what it's doing, it connects with, makes communication between the Raspberry Pi and the reader, checks it's there. And then now I'm going to bring the tag to it. And now it dumps all the information that's inside. So you can see 134 pages because as programmers, we start at 0, right? And then you can see here all these like 39s, right? This is the text representation. There's a little bit in the front that's telling that this is the end tag definition, right? And the length of what's to follow, and then where the message begins and ends kind of information. So it's kind of like sandwiched in. So FE you see here. And then this 39 is actually because it's reading it the other way. It's not read from left to right. In this case, you're reading from right to left. Does that make sense? You guys have any questions related to this? Okay. Okay. And then let's move on. Next part. All right, cryptography. Cryptography is a very complex subject. So I'm going to try to give you kind of this overarching, what's important to us, right? Cryptography is very important for the internet because without it, we wouldn't be able to know who is who over the internet. Since everything can be copied, right? Copy and paste. There is no original document with authenticity, right? The only way we can verify authenticity is kind of using these math tricks that kind of, they're hard to reverse and they would take way too long to reverse. That's how you know only the person that knows the secret could have made that document. It's a little bit into that. So there are two different types of cryptography, right? There's asymmetric and symmetric. Essentially, symmetric just means you have a shared secret, so the key is the same between the two, right? For plain text, ciphertext is kind of like jumbled up text that you can't extrapolate anything from. You can't use the key to extrapolate information from. So symmetric has the same key. Asymmetric has a public key and a private key. The difference here is that the public key can produce the ciphertext, but once it does that, it can't reverse it back, right? Only the private key can reverse it back. It's kind of like a one-way, either or. It doesn't matter which side you start from. The keys are kind of like they complete each other, right? So what the private key does to this, it can't reverse back, but with the public key, you go this way. Does that make sense?
how is like, isn't it like it can go like one direction and it can go there?
Mhm.
How does it like do that?
Okay, so in this scheme, right, one of the keys has to always be secret for you, right? There's just one is public, one is private, right? The way we hide information is by putting it behind really tough, reversible, like hard to reverse functions, right? So the easiest example I can give you is modulo. Do you guys know what modulo is? Modulo is a math function that is used by computers, right? Essentially, what it's saying is, give me the remainder of division between these two numbers, right? If I gave you the remainder of division from those two numbers, and I told you, hey, figure out what the number is, those two numbers that produce this, right? You have to just guess. There's no easy way of going in. Okay, there might be some mathematical ways, but this is the most simple kind of overarching removing of information. But if you already know those two numbers, it's trivial to produce the remainder, right? Does that kind of answer your question? Any other questions? Okay. Second part is hashing. Is anybody familiar with what hashing is? So a little bit. So hashing, you just think of it as a function, right? And then what it does is it outputs a string of a specific length doing a specific number, right? So instead of having a bunch of these keys, let's say I have a list of people, right? If I want to put them all in a list and kind of, you might talk about this in algorithms a bit. The main concept why people would use in programming is so that you have those quick lookups, right? So instead of going in between, if you have an array, right, you're not going to have that array filled from 1 to 0, right? So you can easily go find whatever it is. You'll have like John and then Lisa and then Sam and Sandra, right? And you just imagine that on a big scale. So to find something, you have to search every single one. One way to kind of get around that is by sorting them in alphabetical order. Then it's easier to find someone. But what they like to do is kind of map keys to hashes, and then you have all these hashes which are a smaller key, and they'll direct you to where something is, and then you can go directly to the hash. It's like instant lookup, but it's not perfect because there will be collisions between two. So you can see here the red line indicates a collision, right? So these will be both stored there, but that's quicker to find than doing like a binary search. Let's imagine this is a huge list, right? And then if only these two are on the same, you'll have to search. You'll take the key, generate the hash, then you can instantly go to here, and then all you have to do is search an array of size 2. Instead of going in binary search where you go half, okay, it's not there, the value is larger, then go to that half, and then find it in. Does it make sense? In cryptography, we just use it to get like a signature or a fingerprint, in this case, of a file. That's the main purpose for it. Does it make sense? And to get a fixed output, right? You have a file, because you don't want to convert a file into something else and sign the whole file. In this case, I'll talk about it a little bit later. Any questions? Okay. Hashing and checksums. So this is kind of one of the advantages of hashing, is that it's very easy to verify if something is the same thing, right? So you'll use a hash, like a hash checksum will be called, to check that the file that you've received is the correct file, right? So imagine you have a big code repository and you need to send it to someone, right? To ensure that they've gotten it, instead of sending it twice, so that like if there's an error or something, you'll catch it, you can just send them to them once. They use hashing and they produce this string a small string that's like a couple bits in length, or 100 bits in length, that's way less size. That's a smaller size to check than to just send the whole file again, right?
Like using a sample instead of a whole population.
Yes. So you just compare. It's kind of like what it sounds like, checksum. You're just checking that the sum of these files is correct. Does that make sense? Okay. And then now you can, you guys will have the opportunity to do your own checksums, right? So if you've ever downloaded anything from the internet, generally they will have checksums, but you might not have known they exist. They're kind of like hidden away. So for example, if I'm going to download VS Code, right? I go to this link. And I go ahead and I download download VS Code. You wouldn't notice it, but if you scroll down right here, you have SHA 256 hashes. SHA is, didn't cover that, but it's in here. You could think of them as, they stand for secure hashing algorithm, right? And they're kind of the standard for hashing anything. The most common are SHA-1, SHA-0, SHA-1, SHA-512, which is beyond 256, and I think they have 1,000 something. So if you go here, see 256 hashes. I can see the hash values that are correspondent to that download, right? So let's say I don't know if I trust the download site that I've downloaded this from, or I just want to make sure from compared to the original web page that it's the same thing. If you want to do that, you can open terminal. I have both the commands here. So if you can, so for Windows and Mac, they already have them pre-installed. But for Windows, it'd be cert util -hash file, the name of the file, and the SHA, the hash algorithm you want to use. And then for Mac, it'd be SHA-SUM -a, and then the number corresponding for the SHA algorithm, and then the path to the file. So if I show you that, cert util hash file. Sorry. You also need to be in the same directory. So I'll cd into downloads. And hash file. And then the name of the file. So in this case, I'll go to downloads. And since I downloaded it twice, I can just go here, copy. And then SHA-256 in this case, right? Then it'll take the file and it'll compute the SHA value, right? So if I go to their website, I can just copy the SHA that from this value. If I take this, copy, and just search for this, right? I can see that, yes, I've indeed downloaded a non-malicious file from the website. And I can tell it's not been poisoned or corrupted. If even one bit is changed in the file, the hash function will look very different. Is that good? Everybody? Okay. Okay, and then now we're going on to encryption, decryption, right? So essentially, this is kind of rehashing what I just said, where encryption, right, is where you take some plain text, take someone's public key. Let's say I want to send you a message, right? I'm going to take your public key, use it to create the ciphertext, send you that, and then since only your public key is known, no one can reverse that and figure out what's in the message. Then once you've gotten that, you can take your private key, do the same algorithm, get your plain text back. Does that make sense? Okay. Make sure this makes sense to you. Because the next part is signatures. Signatures work in the reverse way, right? So you'll have a document that you want to sign. So what you take is you take a document, you produce a hash, right? And then you sign that hash with your private key, right? And then you send that over. And they can take your public key. So you'll have like the text up top, and you have the signature at the bottom. They'll take the signature, apply the private key to it, and now they just have the hash, right? And then they hash the same data that you sent at the top. And if they match, then they know that you've sent it. So we kind of think it in reverse. That makes sense. This is probably the difference between the two is kind of important to understand. Any questions?
So what is public key?
Public key is just the key that you openly put out. The private key is the one that you keep secret. You have to keep one, you have to keep one key secret to you. You should only know that key.
So what key?
Key is just so when you generate a key, you generate a number that's mathematically linked together. Two numbers that are mathematically linked together using this kind of algorithm, right? So now public key and a private key are just a number. You can think of it just a number, right? And that number is your key to mixing up, jumbling a text or unjumbling it. Kind of like a password, but passwords is like account management, right? You have to maintain your private key yourself. If you lose that private key, there's no way to get it back, right? The private key ensures that you are you, so only you can know what that is, right? Passwords is kind of think of it as a password, but I'll just think about it as a key because that'll confuse you. So you just have a key, and you can use that key with an algorithm to jumble up text, so it's unreadable by anybody if they don't have the other half of the key to unjumble it. Does that make sense? Does that answer your question? Maybe. Okay. And now, okay. I think we do have time to go over this. So I'm going to drop a link, or you just search up digital signature algorithm. So I'll show you an example. So if I just search DSA, the first Wikipedia link should. Digital signature algorithm. Okay, DSA algorithm. DSA is kind of the most simple algorithm there is. I'll show you. We'll practice an digital signature algorithm, which is just a different way of doing this, so that you don't have to make as long of a key. So it's made from standard from NIST, which is a government, U.S. government, National Institute of Standards and Technology, right? That the US, I think it's the U.S. pushes. Yes.
Oh yeah, you guys might see NIST in plenty of companies because a lot of companies really like to base a lot of their risk frameworks based off of that one because it's like kind of like a standard.
And also pass out NIST certifications, right? So if you're certified by NIST, so to get government contracts, you might need to have your program NIST certified, right? So it follows NIST's guidelines. Does that make sense?
Sometimes some companies either just go straight up with NIST or they kind of bake in some of their own like company-related policies into NIST, if that makes sense. But for the most part, NIST is very good. They have a risk framework. They have a lot of frameworks out there.
Do you want to explain what a risk framework is?
It's kind of like how you approach, um, kind of approach security in a way sometimes. Um, like, let me see. I don't know if you guys have heard. I forgot the specific name, but it's like identify. No, yeah, protect, detect. Let me see. I'll get back to you guys on that one.
Okay.
Let me do it again real quick.
Okay, and then so you can see the operations, right? So relation to how do you generate keys, some of the parameter generation. So parameter generation is just, so you can imagine all numbers as a number field, right? Where do you start in that number field are the parameters in this case. So that is what you use to kind of your base point, so everybody understands where you're running from. I'll go a little bit more into that in a bit. Then personal key, per user key generation also. Then there's key, talks a little bit about key distribution, right? So the public key, which is why it's fine being distributed. Your private key should never be distributed, right? And then it talks a little bit about how signing works. So you can see G, which is a like a base number, and then K mod P. If I told you to find out what K is just from this, and you don't know what K is, but you know what G and P are, it would be really hard. You just because it's an exponent. There's no easy way to reverse it, right? And you can imagine it's not a small number. It's a large, very large number. The only way to kind of figure out the components of K is to just guess. In this case, right? And then it talks a little bit about signature, how do you verify a signature, right? Which is essentially kind of working backwards-ish from here, but it has to use the public key. And let's see what's next. So this is libg crypt, right? So it's a public library. I'll drop this also here. And it is used by GPG, which we'll go a little bit into that. But if you want to check out how do they do those numbers in C, you just go to like Cipher. And then we were looking at the digital signature algorithm. So I'm just looking for DSA here. They have a couple different ones. DSA. And then you can see kind of what is a secret key and one is a public key, right? So this is like a prime number, your group order, group generator, and then this, the result of this function, which is Y. And then this is for your secret key. And that is what, like, how you kind of store the value. If you guys have any trouble seeing, just tell me. So I can, it's kind of hard. And then this is kind of an example that they've given. So P would be this number, Q and G, Y examples. And if you want to, you can look through that yourself and then see kind of how these kind of algorithms work. ECC, which is elliptic curve digital circuit, is digital signature algorithm. So EC digital signature algorithm, right, is very similar to DSA, except instead of relying on this kind of G to the power of a number mod P equation, it uses the elliptic curve problem, right? So I think the simplest way to explain what an elliptic curve is and how they do that number generation, if you want to look more into it, Computer File has a lot of good videos that kind of explain it. But just a quick rundown on what an elliptic curve is, instead of those mod problems, imagine you have like a big curve, right? And you have a starting point. And then to get to, let's say I need you to do that, I need to get to you to get a multiple of that starting point. So what you do is you take your contention line from that point, go to the other point, and then go to another tangent line, go to another point, and tangent line, and however many times, right? So if I gave you a point on there, it'd be really hard for you to figure out how many multiples it is to get back, kind of problem, right? There's no easy way of solving that. That's why ECC private keys are smaller than like digital signature algorithm, just because the problem behind it is so much harder to kind of guess.
What what kind of math is used in this? It's like
Vector math, some calculus. That's kind of the main parts.
Cal 3 or like which level?
Not as much calculus as you think. I would mainly, if I were to approach this, I'd mainly approach it with like vector math, which is, I can't remember which class, linear algebra kind of field. This also touches into information theory, which is its own big thing. How do you pass information?
And will be implementing this or
At the moment, we won't be implementing this. I don't know. For me, this is hard for me to grasp, but we'll see further down the line. We're planning to do DSA, which is the other algorithm, which is a lot simpler to look at. If you look at this kind of like curve math and everything, it's very hard to find information about these because it's kind of, there's no easy tutorial to find this information. You kind of have to do it yourself, right? So we're going to be using kind of like a pre-built model, and then just ripping the parts we want out, modifying a bit depending on what we need. Kind of similar. It's kind of similar to how you might want to run a hackathon, but this is just to get a minimum viable product. Hackathons is you have a limited amount of time and you need to get something that works, so you have something to submit, right, within that short amount of time. You leverage libraries, you leverage a lot of pre-made stuff and kind of stitch it together to create a product. That's what we want to do first, and then incrementally update, like clean up. We can make it more efficient, stuff like that. Any other questions? Okay. Okay. This is an interesting aside if you wanted to check it out. I'll also drop this link. But there is an elliptic curve algorithm that's being pushed by the NSA that, to a lot of people, looks like it has a back door, right? The back door is in it. There's a way to kind of crack it. But the problem is no one can prove that there's a back door, so no one knows. But everyone is, a lot of Microsoft has done a little talk about it. If you go look for it, if you watch this video, it'll kind of really brush you up. And if you're kind of interested in that, that's there for you. Okay, now I'm gonna want you guys are gonna download and install GPG, which is generally, you can just think of it as a program to do this kind of private key, public key, just so you can kind of feel see it working. So I would go to this link. You don't need to pay attention to everything this has. It will have an intro of how to set this up for email, right? But you would need to do that. Just go to the link. And then if you scroll down right here, depending on which operating system is your installation instructions, right? So if I go here, it'll bring installation page. If you also wanted to check the hash, right, it has a check integrity button right here. You check this. This will give you some of the signature information for the certificate. So whenever you pass anything out to the public, so if you're using drivers for something, generally they come signed by the company, right? And this is kind of the signature certificate info. And then if you scroll all the way down, you can see the SHA-1 checksums and the SHA-256 checksums. So if you wanted to try that out, you are able to as well. But I know that if you're following the The instructions for Mac, it tells you to install Brew, which is kind of similar to NPM if you came to the JavaScript session. And it's a package manager, so you don't really get to check it. It just downloads it for you. And then tell me when you guys all done that installation. All right, I guess I'll continue until we get to that point. And also this link. This is kind of like a starter, how to use GPG, to do some of the little things that you guys can be doing. So if I go to the link, it'll give you kind of this rundown. Installing GPG, you don't need to follow these instructions since they're sort of outdated. This document is all the way from 2005. So that's something to look at. But it's all relevant to the program we're using since it hasn't changed that much. So this is where it's telling you how to do the checksums if you wanted to, which I recommend using other. Also, let me drop those commands in for you guys if you want to use it. This is just doesn't want to do that. There's an image of it for some weird reason. Okay, and then there's another command that I would like you guys to use. Let me find the other thread it was in. Okay, GPG -- full generate key, right? So in this other layer thread. Okay. So if you run this command in the terminal, you can use the same command that is in the instructions for generating it, right? But it won't give you the option to see some of the features that it has. So if you run this, right, it'll tell you, hey, which kind of key do you want to generate? So for you guys, if you guys have this downloaded, run this. We're gonna be using ECC, so that since we want a smaller key, right? So that's 9. We want to use the default here. So this is kind of like the parameters that are preset for these specifications. And then how long do you want this key to be active? So 0 does not expire, right? So you can just do simple 0, and then it'll ask you, sure? Generally, you want your keys expire, but it's not really that important. And then you'll put your name in, right? And then your email address. So you can just put your student email address. Also, make sure you type it in correctly. Otherwise, once you generate these keys, you can't change them. And then you don't need a comment. And then you should press O for OK. And then now you're going to get a prompt. This is your passphrase. So generally, you don't want to keep your private keys in what you'd call clear text. Clear text is just written out. So you use a passphrase, which you should only know. So for this example, I'll just put a really insecure one. Just make sure you remember it, because if you don't, it is gone. It is essentially using this passphrase to kind of encrypt it on your file. Yes.
What's that thing saying encrypt?
Entropy is the amount of randomness of bits, right? So when so computers, they don't have a lot of randomness, right? If you run a program once, I mean, depending on how you're running stuff, you'll get the same result out, right? So the way we generate random numbers, since you need a random number, if you don't, that is kind of how we generate the keys. If someone knows the random number that you're generating, then they can kind of figure out which key they can make. It's a lot easier to find what your private key is, essentially. If you look into, I think Sony had an issue where they had, if you go to, I think it's even in the elliptic curve. Okay. Concerns, security. Yeah, so there's a problem in 2010 where Sony implemented ECDSA, right? But they use a static K, which is supposed to be randomly generated. So they were cracked, basically. And it made DA very solvable and kind of breaks down a lot of. That's why you really need to know what you're doing when you're implementing these kind of algorithms. So when it's talking about entropy, and now I've generated the key. This is the public key number it's telling you. But if you go to, what was it talking about? Entropy. So the way computers like to get around this is by taking actual random-ish data that you generate yourself. So here is typing on the keyboard, moving the mouse, utilizing the disk. Those are kind of sort of random. So it takes that input to help generate that random number. And the video that I linked also talks about the backdoor kind of not being the random generator, not being random enough of a generation, right? So, because you don't want to know whatever the random number you're using to generate stuff is. Does that make sense?
Like the more you move your mouse, the more random.
I wouldn't generally ish. You can kind of think of it like that, but your computer manages random generation itself, right? It has kind of like a hidden number on the computer that only it knows. Kind of like how if you came to the JavaScript session, we talk about OS specific stuff that should only stay on the OS and no one else should know. This random number is kind of constantly being updated with random information, right? So your key presses. If you generate something and somehow someone knows that number when you're generating it, then you have problems. But it's just constantly being updated, kind of taking random data from outside. A famous email service, I think it was called Lava something. They actually had a camera and they had a big wall of lava lamps. And to generate random numbers, they take the image, the video cam video of the lava lamps, and then turn that into a number to kind of generate randomness. Does that make sense?
Like that's one number.
Which number? You're talking about this, the public key?
This.
Yes. So I can actually show you exporting it. So you want to publish your public key. So you're going to use this command. So copy and paste this. Paste that into here, right? And I want to pull out this key. So let's say I actually want to go into desktop. And then I paste this command in. And I put this into Hussein -key, right? And then my name. right? Now you've exported your public key to this text file, hussein-key.txt. So if you go to your files and then go to desktop, right here, and you open this, this is your public key.
It's like one number.
It's just one number. Yeah. I mean, technically it's like 4 numbers, but you can think of it as one number. This is the same representation of where it says here. Right, you have these big numbers here. These are the kind of standards here. And then for since you're looking at public key, it's this. But in this case, group order is predefined. That is kind of like when we selected the defaults. That is kind of like the group generator. Group order can be preset by those. So in this case, you're going to give it just this Y. It can be just Y, depending on how you're passing information. If you want to do completely random, make P, Q, and G not preset, you can also do that. But in this case, yes, it is kind of just one number. They can kind of think of it as 4 in this case. And then, now that you have your key out, I'm going to drop my key for you guys to import. So let me pull it up. Is anyone having any trouble running the commands that? And then to import, you need to run this command. Hamper key, sending, encrypting files sent by email. Signing files. Where is import? Yeah, here. So you'll run this in your terminal. And then change the name to what it is. So in this case, it's Hussein-key. Copy. If you guys can run that.
Is that the same name as this file? Oh yeah, it's not. Oh, right. So if you go check where it is in the directory, you should see it. Or just type in Alice. No, just Alice.
Oh,
You can see it
sorry.
there.
Okay.
But I don't know when you drop it. You guys having any trouble doing that?
So even if at this point, like, it's option you
The default, so 1. And then 0. Anything else? Yeah. You just run everything too? Okay, so the install, scroll down. There should be an install instruction for Windows. Right there. So install for Windows, and that's it.
The little passphrase is just like the password for the.
Yeah, for you. So your password encrypting the private key on your computer.
Okay.
I can't wait for a passwordless future.
Passwordless?
It's in the works.
By who?
Let me see again.
That doesn't sound very secure to me. How can you have security without a password?
It's because there's so many like account compromises just because of like poor password management. So people are sort of trying to get away from that.
No, I didn't.
But let me look up that for you, share some articles.
Like the big tech
Yeah,
companies,
that's
like, they make like a consortium with like a standard to try to have a thing to where like generates a key on your phone and you use that to unlock it now rather than like typing it.
Oh, that is-
something like that earlier on Monday.
It was compromised Monday?
Huh?
You said it was compromised Monday?
Oh no, Apple announced something like that. It's like using that standard that they're trying to work toward that next release.
Okay. Not aware of that, so. I do see where that would work. Kind of, but if you lose your phone, you're kind of stuck in the water.
I guess for a lot of people, all they have is their phone.
Mm-hmm. And then you guys should get something like this once you've imported it. Tell me when you've gotten to this stage, or if you need help to get to this stage. Oh, just go through it. You have it imported?
No, the function didn't work for some or the maybe never worked for some. Oh, it's a
And also you have to use the same directory that the file is.
Oh, yeah, it is.
I get a thumbs up when you guys are here. You want someone? Oh, you can just go around. Yes, now it's downloaded. Now all you have to do is open PowerShell.
Yeah, you can create a password.
And just and then now go to the commands of this book. So you should do dpg dash full key generator, right? Then output that out, right? So now you have your own key. Then download my key, and then use this command to import it. Yeah, so now download my key, and then import it into store it on your computer. Essentially. Zoom in a little bit, I think. There's no zoom in. Oh, there we go. You share some of the links? Okay.
Oh, it's in the off office.
Okay.
Are we using the default code?
Yeah, so 9 and then 1. So 9 for ECC and then 1 for the default. We're both in default. I just want you guys to see that there are options, different ways of generating keys.
The key is not.
0 does not. Heard 7-Eleven in Japan is kind of baller.
Oh yeah.
And give me a thumbs up once you're. Oh yeah.
So this can be
fine. It's not correct. It's just that that's what they're going to see. So if I get your public key, that's what I'll see. So it's fine if it's not correct. Just make sure you know what you put as your name, because when you export it, it needs to be the same name that you put in it. When you run this export command, the name has to match whatever you have. Or general language. And then if you're wondering what Cleopatra is, it's kind of a manager. So I don't know if it is seen on this will open.
Yes.
What do you write in the command?
4.
It's giving me a command.
A command. Oh, you usually that one. Just press enter.
Okay, and you're gonna do the import.
You're wondering Cleopatra is kind of a UI way. Once you have GPT installed, you can kind of do all of this
Yeah.
just right clicking. So if I go to any document, I can easily go and right click and go. Should be a. Actually, there might not be. Oh yeah, more GPG EX options, and then import keys kind of options. But I'd like you guys to do the command way. It's the easiest way. Just kind of give you that more manual feel.
We do not need to remember the passphrase.
You do need to remember the passphrase.
It has to be a phrase, not like a.
What was the question?
Like it needs to be a password.
Yeah, just think of it as a password. It doesn't have to be that secure, but it's just a practice. You just put like 1 through 9, just for this example. It's not really that dangerous to have a weak passphrase, since it's only on your computer. It's not being stored anywhere. Unless a hacker has constant access to your computer to guess all the passphrases, you should be fine. It's not like if you have an account up on google.com with a bad password, they can easily just constantly keep checking and just guess and check work. Have any questions?
So like, what is the key used for?
The public key?
Yeah.
So we use it to encrypt and sign. Or decrypt. Decrypt or encrypt and also sign. So the public key, if I want to encrypt something and send to you, you give me your public key, I use it on it, and then since you're the only one with the private key, all them that can descramble that. They can send that. Even if someone else gets it, they can't unscramble or figure out what it sent to, right? Signature is the other way around. So I'll take my private key and sign something, right? Take a document and essentially sign it with my private key, and then I send it to you. And then since you can see my public key, you can take the public key and descramble the signature and see that what you've gotten matches up. Since I'm the one with private key, you know that document has to go.
So when we cannot put them.
Here.
Okay, so you have to download it. You have to download it.
Oh, from this one.
Yeah, and you have to be in the same directory as it.
So this command expert and it's it. Okay, so it should be wherever whatever directory you're going to, and it should be called key.text. Yeah, that's it. And that's however you name it.
Okay. Is anyone not here? Yep. Are you following along? Okay. Okay. And then now I'm going to show you how to sign something, right? So let's say I'll create a document in the same directory. If you wanted to know what nano is for Windows, it's just NI. And then I'll say Hussein-info.txt. I've created that. And I'm going to put some info in there. So I'll put like my name, major, and my favorite snack. And then it's gonna hand you guys out secrets, but that won't work out for this. And I can just save this. And if I go back to here, should be non-encryption. I'm gonna signing files, right? Here is the sign command, right? So if you do the same thing and make your own info file and run this sign command. I'll say local user, I want to sign it, so Hussein. Say, which name did I make? Hussein, yes. And then clear sign so that you guys can see what it is. And then I'll put Hussein info. Right? And then I'll run that. Now it's going to ask me for my passphrase. It's like, hey, you're going to sign this with your private key. Here you go. And then I'll put this that same file, but with ASC. I can't remember what ASC stands for at this moment, but if you select it and then open with Notepad, you can kind of see the format for this. So at the top, it's at the top, it's telling you beginning of the message, right? And then it tells you what hashing algorithm was used to create the hash for it, the info, then the signature, right? So that is the hash. This signature is just the hash of this plus the private key. And then when I send this to you guys, so when you guys download it. So if I go here, I drop it in, right? And you guys download this and put it in the same directory that you're in. Then all you have to run is, I think it's gpg -- verify, and then the name of the file. So in this case, Hussein -info.txt.asc. So now it's telling me, hey, look, I checked it for you, and there's a good signature, right? So whoever owns a private key, the other half of the public key, right, definitely is the one that signed this document. Does that make sense? And then tell me that you guys can get good signature out of this. A thumbs up or any help. Okay. Nope. Okay, the reason why it says it's not a trusted signature is because you haven't assigned a trust level in the system. So if you're using this to manage a bunch of private keys, you kind of want to assign which ones are trustworthy, right? For me, since I'm the one generating them, it'll automatically set it to ultimate. So that is what that is, if it's spitting that out to you. And then if you see this warning for me, warning not undetached file, this file was not verified. So sometimes what you'll have is a file and it's not attached like this, put together. You'll send a file plus the signature separately, right? So in that case, the program is smart. It's looking in the directory, and if you find the original file without the signature at the end, it's telling you, hey, watch out, that file hasn't been verified. What was verified is altogether, the alternate one, which is Hussein, which includes the signature of that. So if you want to see that, I just take it and I take it out. So if I put this here, right? No. I don't want to move it because then I'll have to put it back. But if I did move it, that warning would be gone. And then tell me once you guys all gone to good signature. Good. There you go. Oh, don't use Cleopatra. Run this thing for me.
I have some trouble. I'm just
Because you didn't make a message. You have to make it. So this is the file that I made with my info. Right? So for me, it was the same .info.txt. I had to create this. This is the file I want to sign. Is there any questions with that? Any trouble? Okay, well, that is great. This is the signature. This behind Nancy's signature. Right? So for whatever project, it says message that needs to be something on here. You're saying, hey, this local user, so that's you, right? I want to clear sign something, which is like have it all the same text to create a signature, right? And then you specify what file you sign. So, but you want to, you're trying to just verify that the text that you got was from the, and it's signed properly. You want to basically check my signature for the file. So if I don't know if you downloaded wasn't in this version, with that you saying that so it's in yes. So if you open that, you can see the signature file, right? No, if you open it, oh, okay. If you open a text, it should be able to see it. Can you manually open a text like a notepad? Now you can see, so this end is signature. And this is the document I'm seeing. That's on it. That is the result of me using my private key. So I'm not sending my private key, I'm sending, so if we take the message I'm sending, which is the document that's on, right? We put it through the hash algorithm, which is specified here, show off, from 12, right? You get that number coming. Then I take that number out plus my private key to produce the signature, and that's what you're seeing. So you don't get my private key, you just get the result of my private key. And then since you know my public key, you can reverse it and it comes back to the hash number, and that's the same as what you can generate with the file. Then you know that I have generated that file because I'm the one with the private key. So to run that, the command is going down here. It's yeah, GPG -- verify, and then the name of the file. This one.
Yeah.
and then
Now it should be there. You go down once. Refresh the page. And you just sign. I think it's this. You don't have all extensions on. I don't know the Robbie text here. Since you see the info here, you don't have the extra extension on. So I think it's if you go to view, it close out click right here.
Saving or
Just close out. And then go up to view. Right? Then there should be an option file name extension. See the check mark? The right little thing. Check that. Now you can see the extra extension of that. Okay, so this is the original, and this is the one you produced. You can just close it out. But you want to try opening my info. Just re-download it and then run the verify gpg -- verify and then the name of the file. Well, now that's number one. So include that in the name. Right. Is this? Let me copy and paste it actually.
Have you worked this before? Nice.
I've used it with other programs.
Yeah, so like I have like a Linux server, and so when you kind of like snitch with that, you have to set up like a public and private key.
Oh yeah.
To like the public key. And then I also actually make like a GitHub key.
Hmm.
So you're ahead of the group.
I mean, GitHub forces you to, and SSH forces you to. It's not an option, I think. Yeah. No, there is an option to password, right? SSH you can use password. I think you can use password, but you are technically ahead of the curve. I think now on GitHub they really want you to use tokens. They're really pushing it.
Are you in the directory? Let's see directory. We go back to the file. And you included that space. There's a space there. This? Yeah. This way. There's no space. Thanks. But you're running the command again, but just. Just kind of space that. Okay, now you do a good signature. Now everybody should be on cloud. Okay, now you're gonna manually send a message to you're gonna send a message you're gonna send your information between you and someone else. So kind of like a pair. And then you need to both exchange public keys, right? So put in the Discord and then kind of like partner up pass each other your public keys, and then I'm going to show you how to encrypt your info. And then you'll send your encrypted info, and then the other person will decrypt it. Go ahead, you guys can talk. Don't be shy to talk. So pass each other your public keys, and then get to that point. You can use the thread as well to paste it in.
I said, I can't believe that coffee's getting turned
When you said medium, I was like, you didn't see commonly when you came in there. Pretty calm.
Or like, yeah, like I've never seen them before. Or I don't think I've ever like found it. So I was like, maybe. Like based off of just his head shape, I guess. Like during one of the calls
Yeah.
that you were on. Like when we were initially trying to get everything ready, you know?
Put it in Discord,
Other than that, I've never met him IRL before.
This is being dropped off the hard way.
Oh.
So this would be long and travel with what
like, just send it.
Oh yeah. Now I know what you're doing.
It just rolled to lock the office.
Yeah.
We still need to send those postcards.
Yes. Yeah. Like initially, Shorter said that he was in Oklahoma, but like
Either or we do.
understandable that now that he's back in work, the first week can be the busiest. Now to catch up with everything that's happened.
Yeah.
You joining us? You come on.
Oh, yeah. Like I never. Yeah.
I'm having it over. So they just send over the key, right? Which is this one.
Yes.
And then put it on Discord. I can put it on Discord. How do I export us to Discord?
Press the plus.
It is disappearing, right?
Oh, hold on. I might not have that. Let me enable that for you guys.
Okay, I was like, it might just be over. There we go. Yeah.
Okay. Now you should be able to do that.
Okay. We're going to download it. Save that to. Yes.
I think it's this one last time. Yeah. Yeah. That signature, and then everybody had to leave. So,
How many people?
how many people? There are 13 people.
Oh, okay. So good try.
Yeah, good shot. 13 plus. Actually,
Yeah.
we have 5 people here. Plus,
Plus you.
Yeah, so 15 people total. So 10 people in our conversation. Not 15. 15. No, it is 13 because there was 2 people within inside. So I'm 12 plus 5, so that's 7.
Have you ever heard of RSA conference?
Yeah.
I wish I had. Or I guess I haven't
They all-
gone to security.
RC is always in, what's it called? Las Vegas, right?
Oh, is it?
All the ones I'm interested in are all in Las Vegas. I know Black Hat is in Las Vegas. I think RC is in Las Vegas.
I don't see where it was at, but I'm just like, man. Like maybe I could have gotten the shirt and stuff like from my podcast heroes there, because they're there. You see the photos on
Oh, you
LinkedIn, and I'm like, yeah,
Perfect.
maybe someday.
Have you guys gotten a chance to import?
I got hurt in court. After we do the import, we need to verify.
No, you just
It's just, there's what's it for that's included, right? And then you can get the import.
now you have their public key already set up for you to check. That's what you try to
I
get.
put my key into the text.
What's that again?
Because your text, right? It posts something you just have to use your phone.
No, we're doing encryption now, so that's not signatures. You verified that what I sent came from me. Now you're gonna encrypt information and pass it to me secretly. So now you both need to have each other's public key, right? And then the message you want to send, you sign with your private key, and then send it over.
So
We're not there. We're just trying to get everybody to have your public key. Yeah, they're also you have each other's public key. It's important.
Yeah.
Okay. You guys both have each other. Okay. Now, how do you sign? How do you encrypt stuff, right? So this is the encryption command. Okay. So this is the command to encrypt, right? So now you have your name info.txt that has your name, your major, and your favorite snack in it. Right? Now you want to encrypt it. So to encrypt it, GPG, right? And then dash dash recipient. Recipient. And then the person's name that you're sending it to. So I'll pretend, Paul, if you want to drop your public key, you don't, then I can import it first. We've paired up and passed each other public keys. So if you can drop that, I'll import it.
I didn't know Trump was going to try to stop that. Oh, the public tea. I saw him doing it.
Oh, he stopped by right now?
He's going to try to drop off the.
Oh, okay. Say again.
What was the key for or command for exporting?
Exporting command would be GPG armor export. So name, say paul.key.txt, and then export, and then your name. Right.
sent, the export failed.
And that's the same name.
No, I had,
Oh, you said
Well,
no
actually,
to
it's-
over. Oh, you already have it exported.
I,
Or go to your files. So where
oh, no,
you already exported it.
yeah.
So you can just, if you just drop that in.
Perfect.
Okay. If you can just, can you drop the whole file itself?
Yeah.
You can just drag and drop. Or if you press the plus button here, you can select upload a file. Okay, so now I'll download yours, right? Completed. And then now I'll import it. So GPG dash import all that text. Right, now I have your public key. Now I want to sign it. I want to send you a secret message, right? So I'm going to use this GPG dash recipients, and then your name. So Paul, what do we have here? Paul Park. I want to output. What do I want to call the output? Paul message .txt, right? .txt dot GPG, right? Or I can just say txt actually. And then dash encrypt. And then the name of the file that I'm sending, the secret message I'm sending to you. So for me, that would be HusseinInfo.txt. Info.txt. Actually, let me put the thread again. And I'm running. And then I run this. There's no assurance this key belongs to the named user. It's giving me a warning since I didn't set a trust factor. You know, certain the key belongs to the person you named. Okay. No such file in directory. Oh, okay, I have the CD into it. Then I run the command again. Yes, please run it. Now it'll create this file. So if I open this in text editor, right? So you guys can see what's in it. Notepad, and I open this. You'll see it's just a bunch of garbage in there. It's just a random string of numbers. You just don't know, right? So now I'm going to send this. So Paul, if you can go ahead and download it. Let me upload a file. Drop this to you, right? And if you go ahead and download that, all you have to do to decrypt it is run this command. Right? Run this command and change the name to whatever the name of the message you've been sent. And tell me if you guys have any trouble. It should output to you the decrypted file. You don't have any trouble? Does it work for you guys?
Yes.
Yes, it did work. Or
Yeah.
so you got a message from RJ. Yeah, now you're sending a message.
Or she's trying to.
Have you ever been to a pretty conference before?
No.
Same. I really want to go,
Just make sure you're in the same directory.
especially the RSA conference that happened basically this week. Jen Easter was there, the director of cybersecurity and infrastructure security.
Oh,
Says,
does it happen like?
like a lot of them are actually happening in like kind of Vegas. Like a lot of like, well, there's still like conferences around here. But I guess like a lot of them kind of tend to sort of over there for some reason.
Yeah.
Wink, wink, mention that. But yeah, it'd be nice to go. But I mean, thankfully there's still like organizations.
Oh, that's fine.
Like, have you heard of DSOS?
No.
Dallas Cyber Association?
Never heard of them.
Yeah, thankfully there's like plenty of stuff around there. Are you only part of Moby?
Yeah.
You only run social?
Oh, you didn't send that.
That's it.
It's not structured.
It is.
Yeah.
Yeah, but I normally try to share a bunch of like stuff like that.
Can you walk me through it? Just make sure see what I missed.
I think you already have. So go to the directory. Or just press this.
Yeah.
You already have.
Alright.
When I went to meetings or
Yes, you already have.
Like basically right after the Moby meetings on Fridays, 5 to like 6, 5 to 7, depends on the meeting.
Just drop it.
But yeah, we've had
Actually, open that.
we have a variety of things. Sometimes we have guest speakers, we do game nights, we do sessions very much like this. Yeah, Facebook.
So what days?
Normally Fridays, but it also depends on, sometimes we have recruiters come in as well. Like,
Stuff like that?
yeah, have you heard of Mandiant before?
No.
So Mandiant, formerly known as FireEye, is like one of the big players in the cybersecurity realm. When it comes to like threat intelligence, like keeping an eye on like a bunch of like cyber gaming and stuff like that. Yeah, we had it back in February, and it was like on like a Tuesday afternoon.
Oh, yes.
So yeah, we got to keep an eye on the announcements since not all the meetings are on Fridays. We had Lockheed during lunch on Wednesday, either last year or like the year before. Goldman Sachs last year, I think also on a Tuesday since they were there all day. But yeah, we often have all kinds of recruiters wanting to push people. Yeah. They have questions.
So like, what do they like talk about in like the meetings and stuff?
Like which of the meetings that I mentioned, like the recruiters or like the guest speakers, or
Both, but more about like recruiters and
normally the recruiters, a recruiter comes in and they bring in like other representatives from the company, like a security consultant, for example, and they get to share a little bit about their experience, what kind of like work they've been doing, and how they got there. What's that? And normally a lot of them are also very open to providing kind of references or like because you showed up to that meeting and if you apply to some of their roles and let them know like, hey, I applied to this role. I'm from here. I went to your recruiting event. Doing cybersecurity club. Like I know with Federal Reserve Bank in Dallas, they were cool with that. Mandiant was cool with that.
after
I
that.
think Lockheed, Lockheed was cool with that.
No, but
But yeah.
So it's also lots of like that work with like recruiters and
Oh yeah, definitely.
like what other stuff like happens to them? That's said more about like cybersecurity.
You want to do that?
So normally for every
That's
semester,
what she said.
in the beginning, the first meeting is like to talk about the different like cybersecurity
Okay,
groups
yeah,
that
yeah,
are out there, and then the
okay.
next one would
They
be
got the
like,
names.
Okay.
Right.
well, along with that first one,
And then now you
with the cybersecurity careers, we also provide like a lot of like good starter resources for people.
should be.
And then the next
You go to file.
meeting after that is usually they talk about certificates. Yeah, like Security Plus, CCNA.
And like this one that you guys like talked about earlier.
A little bit. Like I don't know a lot about the NIST certificates, but I think those are more so for companies to be able to work with the government, if that makes sense.
So now you can
Oh.
say.
Like let's say if a company has very poor security, the government will probably not want to work with them.
Yeah.
Yeah. I'm pretty sure that's what he meant more so.
Okay, I got it. It was just like for individuals. Really.
They might actually. NIST is such a big organization. But
And you guys pass your messages? Yeah. Okay, and then I can pass, so were you able to read it?
Yeah. This one, right?
Yes. And then if you want, you can send me one, and then I can, just so you can learn. So if you want to go ahead, make similar file to that, and then run this command. And then you specify to me, so where it says recipient, you put my name. And then the output, you can put the same message right here. And then encrypt, and that's the name of the file. Oh, you want to send it.
Okay.
So this is the output. So this is the file you want to encrypt. This is who you're sending it to. And then this is the output. Where it's
Okay.
I think this will be the last thing. Do you explain it again?
You just make a blank GPG file.
No, you need to make. So do you have something like this? Your version of this.
Yeah.
Okay. So now, then that is all you need to make. Now, you run this command. So you're gonna say recipient need the same thing, right? Okay, this is the same thing. And then dash hash output, and then put the name of the file you created, and then add GPG. And this can be the same thing. Or actually, you probably want to specify this message.
And you're doing the GPG recipient.
So he doesn't have this. Swan.
Oh, it is just.
That's why it doesn't.
Can I just press yes for this?
Yes. Okay, now you've created a file there. And then if you said that to me, I can.
This one?
What was the name that you signed it? Yeah. Yeah, if you drop that in, I'll show you the decrypting and stuff. You can either drag or drop, or you press this plus button down here. Okay, so now I'll download your file. So this is a secret message. So if I go to downloads and I try to open this up, so imagine someone has somehow gotten the secret message that you're trying to send to me, and they're trying to open it. If they try to open it, we go here, open with Notepad. They should see just a garble, right? Doesn't make any sense. They can't extrapolate any of the data, right? Now I just have to go and CD into it. So I'll go, okay, CD into my downloads. Then I'm gonna go GPG dash dash. It's verify decrypt. Okay, yeah, decrypt. So I'm running this command up here. Now place the name of the file. So text.gpg. I'm going to put my secret can. And then it'll generate this file back. So now I'll read the message you sent to me, some kind of secret message. Has everybody been able to pass? Are you guys having trouble in the back?
Yeah,
So it works? Or not?
I don't know.
Wait, that's not what you said?
Yeah, it's not pricing.
This is what you had said before was encrypted, and it was, so that's all the right on the computer. Even when you said puzzle,
Oh, we can open it.
yeah,
The actual so see what it's saying. Is then include this stuff.
Yeah.
And then now you can go in. You can go.
see, that's a real one. Like, just looks pretty.
You just listen. No. All right, just delete everything. Or make a new file. Open that. Like open a new folder. Just put folder in right here. And then
For those who, yeah, there's a, those who know from the, those computer,
I don't see that. And then now
you need cybersecurity alerts.
put it in there.
So that
like you get so fun. And like
Oh, it's in the notes.
the creators and some of our guest speakers who are very willing
When you
to
download
provide
it,
like
it's in the
referrals,
Oh, yeah, that can't change.
people that went to need a
Oh,
recruiting
yeah,
or
oh,
a
yes.
guest
That's what,
speaker.
yeah.
Guest speaker.
Okay, so put it then.
you haven't checked like cybersecurity.
Well, maybe they probably would still, but since like normally in an applicant tracking system, there's a bunch of people, especially for very popular
I think you
entry
might have
level
picked the wrong file.
and the second hand, right? Or like the field develops. So normally,
They-
even
they
if you
did that earlier.
do possibly have a cybersecurity related project,
Okay, so
sometimes
you open the download file,
it
right?
could be hard competing against.
Create a
like,
contract
so many
automatically
people. So
interface.
sometimes you get a little referral from somebody that's inside already, can actually.
Yeah, you didn't see it yet. Can I see that? Correct.
Then also, depending on the company and on the role, sometimes they don't really require,
Can I see that file?
so much technical stuff. Like the InfoSec intern for the Federal Reserve Bank of Dallas last year, they didn't really have any like IT experience beforehand. And like they were only like in information systems or like an IT teacher. But because they were able to demonstrate that they had really good critical thinking skills, good communication during the interview, they got it.
Okay, where's the
Well, so
file?
that was for an InfoSec internship. I don't think that one, because I also sat through that same,
You sent my info. He has it on his
interview.
computer.
and they didn't ask me for
It
anything.
says- it just says my info.
But imagine if you were trying to do like a DevSecOps maybe,
Okay. Go to the open the
like more
file.
like software
Add
development, your
something
course like
to
security or
put your
something,
name.
I imagine that could take mine.
And your name.
But yeah, I'm not.
Yeah.
Supposed to be like,
They don't like ask people how to get.
It's supposed to be jumbled up.
yeah.
Oh, well, it also
But we had to
depends
do
on the
it
role. Some,
automatically.
like various roles in cybersecurity, not all of them are technical, or not all of them require
Perhaps it's
coding.
on-
Maybe some of them might like a little bit of scripting, but not all of
Yeah,
them
that's
like
what we were
require
having
like
to do over here, 'cause I
super,
was doing.
like,
That's why-
deep code, like that kind of experience.
If you open it, you can open on Windows, it's kind of like a, it's just a program.
Like
you can
for
use.
a-
It'll do all-
for a bunch of, like,
stuff we're doing
internships in
automatically.
general,
I don't think
they
have the version
try
of
to
that.
see where you're
So
at
that's what
and how do you handle those kind of
So
questions.
you
Because
can do
sometimes
that.
people
So
either try to
if you
fake
go in
it
there and you change
just
something,
because
you can
they
send
already
that
know
over,
their stuff,
and
they can tell when you're
if
trying to
you
like,
don't open it with actually
Trying to fake
from
it.
from scratch.
but
It's actually, I don't have to do it.
they also try to see like if you're
Um,
actually honest to you, like
Yes.
you have some of the maturity to admit that you're not familiar. Or, in the case if you are not familiar, then you would try
want
to
that, you
mention
put more info in there.
what you would do
Yeah.
I want to see it.
get
Just
You want?
so
Okay. So send it to him again.
try to really give you
And then you just close out Cleopatra.
Oh,
And then he'll open it, right click it if you want to move it.
for that,
And
for the most part, just
That was my
learning
thing.
cybersecurity.
this is the one right there?
Yeah.
Because if I remember right, for me, like one of these cybersecurity related things that
I
they
guess
asked me is if I could describe place privilege, or if I could describe asymmetric encryption.
I mean, if there's an appropriate one.
So I guess like stuff
There wasn't there
that's
anything.
still pretty basic,
It was only this.
like technical things, but give me some guidance sometimes.
See the
Like
hardware
even me, like I don't know if you guys may like
on the package.
assume that I'm like
No.
implicit growth, I'm not.
Is it
But
on-
I, at the time of that interview, I did feel fairly confident, to give an
Was
explanation
that
of
at the
this
office?
privilege.
I can see it.
But after that interview, I realized, oh, the example that I provided was about confidentiality rather than use privilege. Sometimes mistakes like that.
Oh, it's
Um,
Oh, yeah.
Like
Then I didn't see it. What's in
yeah,
there?
making sure that you have a decent
I'll
cybersecurity
go back to the office.
Like, for example, I know a lot of people try to grind through those cybersecurity certs. And ideally, yes, it's really nice to have those, but if you don't actually remember the content on there, then the certificate is lost. Because some companies write certificates to see like, oh, this person knows what they do, but it's not always a guarantee.
You won't want that? I mean, if you can download it.
There are some certification classes, but like, it's not the best sometimes.
No, you see the little air button?
It's probably better off learning from like LinkedIn Learning, which is free for UK students, or through Toastmasters, or a bunch of like other stuff as well. I think he does have a blog there, but like he has a bunch of videos prepared for this.
And then-
Let's come together.
And then now, if you want to.
Yes, as well as his website, where he has like more practice questions for them,
The CompTIA was
or security.
also.
We're 10 minutes over. So we just wrap this up. Were you able to decrypt the file? Or no, sorry. I was the one to decrypt it, yes. So I got your secret. And then now go forward. There's an unrepeatable bingo. So I'll just talk briefly about how we'll be doing a little bit of networking. So I have all the network code on the Raspberry Pi. So if I open this, it's actually what, if you guys have done the recent 1106 class or 1205, they had you do, have any of us done the chat app? Okay. So about half of you have. So if you do take it, I think it's, yeah, chat app, right? So if I open this, I can show you kind of what it's doing. So what happens is, can I zoom in? Right, you have a listening port. You can kind of think the server and the client, they use two different ports. One is kind of, and one assigns it as the listening. So for itself, that port would be considered its listening port, and the one that it sends it to is like the sending port, right? So for example here, this is where you set the remote ports, whichever one it is, depending on if you're the client or the server, right? And the mode, which one is sending first? This is what send mode is. And then here is the actual code to listen in. So you're in sending mode. Sending mode is true, so it'll run this block, and then it'll send data. To that port on the IP address that you're specifying, right? the IP address is kind of, you can think of it as your address for the Raspberry Pi. So it sends data to that IP address through that port, right? And then on the other side, it's listening from that port. And then you kind of switch roles between each other. One is listening, and then the other is one listens to wait for something to come through, and then once it gets sent over, then it sends something back. Kind of one switching roles between each other. That's how we'll have kind of the networking setup. We'll have one, there's multiple, right? So we have one that's the server, and all the other ones it's listening to, and then it'll be constantly listening and sending. Since we don't need the server to listen, it'll be listening and then just sending out. That's all we need to do. That makes sense. And then, if there aren't any questions, that's all for today. Feel free to go. Rosh Hashanah.
Hey.
You guys have any questions? Okay. I know we kind of went over 15 minutes. Sorry for taking some of your time.
I guess some mini announcements. We'll be posting the schedule or the time frames later tonight for next week's sessions. It'll mostly just be like, since next week you guys will have more time to practice some of the technical stuff we've been showing you.
Oh, you can keep it if you want.
Like after the sessions next week will be an opportunity to work together here. And the other half would be me doing a mini presentation on like how to present and like some business communication stuff. Am I missing anything this time?
Nothing I'm aware of.
All right, cool. Thanks, guys. Have fun. Stay safe.
Rosh Hashanah.
Hey, let's go.
And now you have a secret buddy to send messages to if you want. Become little pen pals. You can keep it if you want.
Okay.
Did you want me to show you?
Yeah, indeed.
Okay.
I don't think it's like compatible with my phone.
Oh, okay. So I can read it. This is like what it pops up. The info.
So we'll be like interfacing with all this.
Yes, this is kind of the data. If you want to look at the raw data, I'd go to here, read edit memory, and this will show you the raw hexadecimal values that are in there. So this is the same as what you saw that I was reading from the Raspberry Pi. So this is the data, and then you see the 39.
Yeah.
You could see it as well, and then there's the ending bit here.
Yeah.
FE.
Oh, it's fine.
That's kind of just kind of an interesting.
Yeah.
I don't know if you want to try it out or something.
Like which thing?
Hmm?
Like try out what?
If you want to do something else, or it's kind of I want to give you guys the opportunity to try it out yourself.
Or like
Like you can write to it. So if you want to write something to it,
I know them. Okay.
so you can. If I want to add a record, right? There are these other records I can add. I can URL text. So for this example, if I want to write a bunch of sixes,
Coffee maybe or something, or Friday or.
and then I add that, and then now I can write that. That's 55 bytes.
He unironically covered either Call Me Maybe or Friday.
And then if I read it,
Oh, I don't know.
memory.
I'll find it and send it to you. It was something like that genre.
And then I can go down,
I know what it is. I forgot
and
what
it's
it is,
36. 36 and has the decimals 2 8s together. Makes sense?
so we'll be like storing data in this.
Yes.
What like user data? Or like,
They're a certificate. So
okay.
so we generate that first certificate, and then we give them a new certificate whenever they get points. So every time they come to a meeting, they get more points. That's the
The tag is just, you think of it just a certificate holder.
And it has limited memory.
Yes.
So will it get full?
Yes, if you keep no ish. The way we'll make our we'll talk about that more when we get to that, but we're gonna format it in a way it's only one number that changes, right? So you have the things that I know are gonna be on there are your name, right? The date that it was last signed, and the points you have, right? So that's a very small amount, and then now you have to have a signature on that of that data. So
That public usage.
no, what was on the end of the file? So in the files
Oh, there's
piece,
a hash key, the SHA 256. That
the 512.
okay.
I mean, hold on, let me see.
SHA.
Here
Costume.
is this one. Open with.
I haven't seen Travis.
No
He's
bad.
using any summer glasses.
Okay, yeah, this one. So signature at the bottom. So you have your text, whatever the data, right? And then below it, you have your signature. So this is
Yeah, he's
kind of
been
think of
algorithms.
this part is the name, date, how many points you have,
Ready
and
to
then this
draw.
part.
Well, it is what it is. 9 weeks left and we're so good.
Yeah. This?
It's not too
Later.
It's like not too
Later. Have a good weekend.
If it's not if you're private key and public key are not randomly generated, yes, this could, yes. But random enough is like, it's a vague way of saying it. Like, generally it should be, as long as it's random, it's fine. It's just that it shouldn't be random guessable, right? So some random generators, right, all they do is they just move a couple bits around, right? So for AI for games, to do random behavior, they move a couple bits around.
Maybe like brute force.
Oh, they can't prove it. The number of possibilities for this is massive. So it's not really an option to brute force.
Isn't it like there are more possibilities than the number of patterns in the universe or something like that?
Yeah,
Really?
yeah. Like on that kind of levels of it's just combinatorics, just how exponentially larger, like adding one number onto that.
Yeah.
Because it seems like a very big number.
Oh, it is. It's a big number.
There's a biggest number. What's that?
It's I don't remember what the name it was. It is a number. It's just this is the way that the text is represented.
Like a
You know, like how hexadecimal is.
oh,
You know. So the underlying value is there. It's just that you're representing it as characters.
seems secure.
I mean, if you can crack this, right, I'll be very impressed, and you'll destroy the internet.
Yeah.
So if the private public key doesn't work, and you figure out a way to somehow extract it. First of all, they're just going to change the method that they're currently using. They're going to drop whatever method is broken.
Yeah.
But for that amount of time, if you keep that a secret, you could bring down the internet.
Actually, you could do a lot worse than just that.
Yes. If you know how to do it, you can steal all the crypto on
Whoa.
Bitcoin's blockchain. You're just like,
Yeah.
okay, you figure out what their private key is, and then you just send because the way crypto works is you're sending a document to the blockchain, right? You kind of think of this like that. It checks that, hey, with your public key that this is like makes sense, it's from you. So if you can't do that, if you can break this, you can send commands to. This is just one huge network of computers. They don't care what it is, as long as the math works out, you're good. So you can just send a command, hey, dump all your Bitcoin into this wallet, your wallet.
So people must be trying to do that.
What people are
They can
trying to
try.
do?
They've been trying. It's just
It's not possible. It's just not possible. It's like breaking a universal constant. Like imagine one day someone tells like Planck's constant is not Planck's constant anymore. I proved it wrong. That breaks like everything, all the theories that were built on it. So the thing is like most software is built on a principle that no one can ever possibly crack. And if someone does it, it breaks all of them down. Like
the whole pyramid falls down.
That's how websites, you're at the website you were at. So the only reason why it's ICANN, they're the ones that hand out the websites, right? They're the ones that sign keys, and those keys sign other keys to the providers, and the providers sign your website.
Yeah.
It's like a huge chain of keys.
I can always
ICANN, they're the ones that send give out domains.
I can't.
It says, I think it stands for international.
Something. I don't know. I only saw when I was like getting my domain off of Google. Yeah.
Also, to like, have you ever heard of Glassdoor? Or like, have you ever been on Glassdoor?
yeah, beyond that, you can
Oh, okay. Yeah, depending on where you want to go with your career, keep an eye on the job descriptions. If you're like wanting to lean into cybersecurity stuff, because depending on the company and depending on the role, sometimes the job description there could be completely different